So in today's lesson, we are going to learn how to solve by elimination when the coefficients aren't the same. So if we look at our first example here, we have 3x, so the coefficient is 3, and in the second equation we have 1x, a coefficient of 1. Looking at our y's, our first y has a coefficient of -5, and our second y has a coefficient of 3. So we can't add these equations together to get one of the variables to eliminate, and we can't multiply by -1 either because none of the coefficients match up. So what we need to do then is multiply one of the equations so that the coefficients do match up. So looking here, I notice my second x, if I multiply that by a -3, it will match up but be the opposite of the 3x in my first equation. Now I can't just multiply the x, I have to multiply the entire equation. So I'm going to rewrite my entire system. So here's my first equation, that's going to stay the same. 3x minus 5y equals -2. Distributing the -3 to everything in that entire equation. Remember, whatever you do to one side of the equation, you have to do to the other. So I'm also going to multiply that 4 by -3. So my second equation turns into -3x minus 9y equals -12. Now when I look at my equations, my x's have the same coefficient, opposite signs, so I can go ahead and add them together or solve by elimination. So my x's cancel. -5y plus -9y is -14y. And -2 plus -12 is -14. So when I divide both sides by -14, I get y equals 1. So now I need to solve for x, so I go back up to one of my original equations. I am going to use my second equation before I multiplied by the -3 to solve for x. So it becomes x plus 3 times 1 equals 4. Need a little more room here. So 3 times 1 gives me 3. Subtracting 3 from both sides, we get x equals 1. So the solution that I got was x coordinate, y coordinate. And our last step, as always, is to check to make sure that our solution works. So we're going to go back up to the first original equation, replacing x with 1, replacing y with 1. Does that equal -2? 3 times 1 is 3. -5 times 1 is -5. And 3 minus 5 is -2. So that one checks. Let's take a look at another similar example. Same thing, we need to figure out which variable we can cancel easily. So again, looking at my x's, if I multiply my first x by a -2, that will cancel with the +2 in my second equation. So I'm going to start by distributing that -2 to my first equation. -2 times -3 is +6y, and distributing it all the way over to my constant as well. That's a common mistake students make when they try to solve by elimination, is forgetting to multiply both sides of the equal sign by that number. Our second equation we didn't multiply anything by, so I'm going to write down my 2x plus 2y equals 10, and I will solve by elimination now. Adding my equations together, -2x plus 2x cancel, 6y plus 2y adds to 8y, and -2 plus 10 is 8. So when I divide both sides by 8, I get y equals 1. Solving for x, I'm going to go ahead and use my second equation. Substituting 1 for y. 2 times 1 is 2. Subtracting 2 from both sides, we get 2x equals 8. So when I divide both sides by 2, I get x equals 4. Writing my solution as an ordered pair, I have x coordinate was 4, y coordinate is 1. So I need to check that in the equation that I didn't use to solve for x. And again, ignoring the multiplying by 2, we're going to check it in the original equation. Substituting 4 for x and 1 for y, we get 4 minus 3, which does equal 1, so that one checks.